Okay, let's start the pre-lab. So this is the pre-lab questions for the titration curves. And the first question is basically what should the curve or the graph that you're constructing here, what are the axes? And it is, in the past we've done this in a variety of ways, but this is a titration curve, so it's going to be graphing the pH, and that's measured using a pH probe, and that will be versus the total volume. That's what's important here, volume of NaOH in milliliters. So 0, 5, 10, 20, and so on. And each time you'll be adding with a barrette. You'll want to mark the total amount of sodium hydroxide, not each increment. So first you add 5, well, first you add 1 milliliter, and then you add a second milliliter, and so there'll be points along here that you'll draw on, and that's important. The second question is, so we're given a 0. Each of these numbers will be different. Mine was 41 grams of KHP. That's how much I weigh. And then the question is that it is required 21.53 milliliters of NaOH to neutralize that, to reach its equivalence point. That will give my equivalence point. And then the question is, what is the molarity of the sodium hydroxide? So that will be in moles per liter. In this particular calculation, right, the reaction is going to be a titration between this HX, and that's the KHP plus sodium hydroxide, and that yields water, plus this NaX salt. These are aqueous, and that's a liquid. So our concentration of sodium hydroxide will be, we weigh out here 0.50, I'm sorry, it's 0.4881 grams of KHP. Weigh that out. KHP, you're given the formula, and the formula for KHP is that I think I get 204 point, I'm sorry, I think that's 104. That's 204.22 grams for every 1 mole of KHP. And you're just going to have to look that up. The formula is given in the lab. That allows me to cancel grams, and that particular calculation is 0.4881 divided by 204.22 equals, and that is 2.390 times 10 to the minus third moles KHP. Now that's the number of moles at the equivalence point. That's what causes the indicator to turn. But what we want here is the concentration. So because this is a 1-to-1, this is going to be also the number of moles of sodium hydroxide. So it's going to be 2.390 times 10 to the minus third moles of OH minus. And in this case, we have added, what was that value? That value was 21.53. So divided by 0.02153 liters, and that will give you the molarity. And in this case, that's 0.111 moles OH minus per liter. That's the molarity of the sodium hydroxide, and that's question 2. That is our standardized solution. The reason we do this is that we can weigh this out very precisely. That delivers a certain amount of moles, and then we can do the titration to figure out what our molarity is. And in any case, it should be around 0.1.